Today we are on the topic of Chapter 8, One Simple T-Test when sigma is unknown, in Chieh-Chen, Bowen's Straightforward Statistics, published in 2016. The formula for one simple t-test is t equal x bar minus mu. X bar is the simple mean, and mu is population mean, divided by x bar. X bar is the estimated standard error of the mean, which is calculated by s, the simple standard deviation, divided by the square root of n. And this particular t-test has a degree of freedom equal n minus 1. Okay, let's use an example. This example can be found in page 242. This is exercise problems number 1. A car manufacturer advertised the fuel efficiency of one of its most popular models as mu equal 29 mpg. Fuel efficiency is normally distributed. Assume that a sample of 9 cars is randomly selected by a third-party, non-profit organization, and the cars' fuel efficiency are measured as these 9 numbers presented here, and use alpha equal 0.05 to see if there is truth in advertisement for this car manufacturer. Okay, let's use Excel to calculate that. We have 9 numbers. Third-party, non-profit organization randomly select 9 cars of this model, the same model of car, and here are the fuel efficiency number. And based on the problem statement brief review, mu, the car manufacturing claim their fuel efficiency number is 29, and then there are 9 cars, sample size equal 9, randomly selected for this test. Okay, so here is the T formula, and compared to the information we have mu and we have n, so we still need S, the sample standard deviation, and X bar, the sample mean, to answer this question, to be able to conduct a t-test. And so out of the 9 number presented here, I think you know how to calculate sample mean and standard deviation from here. If you don't remember, you need to review chapter 3. Okay, so right now I'm going to do things slightly different, a little faster. So for the sample mean, it could be easily calculated as equal sign. That's where I want to put my answer, and you just simply type in mean is average. Okay, and highlighted the number you want to calculate average on, and close the parentheses and hit enter. Sample mean is 27. Okay, so now next we need to calculate the sample standard deviation, S, lowercase s. In Excel, it actually already have pre-populated function you can choose. Standard deviation. As soon as I put in ST, it shows up a menu right here. So the standard deviation for a sample is simply standard deviation dot S. stands for simple. Okay, so that's the function, and here are the number you want to calculate the standard deviation for. Okay, so those are the 9 number, and hit enter. Okay, so this is 4.6. Might have too many places after the decimal, so we can decrease it a little bit. So 6.4 would be enough. Okay, so simple mean is 27, simple standard deviation is 6.4. Let's go back to the question, and because we are required to do to use alpha equal 0.05 to do a hypothesis test to see if there's truth in advertisement for the car manufacturer. Okay, so 4-step hypothesis test process. Step number 1, state the pair of hypotheses. Are they telling the truth, or are they not telling the truth? So HO would be mu equal 29. H1 would be mu not equal 29. Okay. Step number 2, identify the rejection zone for the hypothesis test. Based on the hypothesis, you can tell, because the not equal sign tell you it's a two-tailed test. We are conducting a two-tailed test with alpha equal 0.05, degree of freedom equal n-1. In this case, n is 9. 9 minus 1 equal 8. So we need to look into the t-table to identify the rejection zone for two-tailed test, alpha equal 0.05 with degree of freedom equal 8. And then based on the table, we find our rejection zone would be absolute value of t greater than 2.306. So the rejection zone is in the shaded area on both tail. And so you can see absolute value of t greater than 2.306 right here. Continue on, done, and third step is calculating the t-test. The t formula is x bar minus mu x divided by square root of n. We calculate the x bar based on those 9 numbers. X bar is 27. Mu is 29 as the car manufacturer claimed. As the simple standard deviation based on the 9 car is 6.4, and there were 9 cars divided by square root of 9. So here's all the number, and the calculated t turned out to be negative 0.94. Okay, in step number 4, make the correct conclusion. Compare the calculated t negative 0.94 with the rejection zone absolute value of t greater than 2.306. We find out the calculated t is not within the rejection zone. Therefore, we failed to reject it. Basically, the evidence is not strong enough to accuse the car manufacturing of lying. So we basically say, well, if they are not lying, it's close enough to the truth. So we have to accept there is truth in their advertising. Okay, I hope this is clear. See you next time.